Good morning, everyone. This is Mohammed trying to solve the weekly challenge 75, task 1 in this video. You must be wondering what I'm doing on Friday morning. Well, it's a long weekend in UK, so I just thought of taking a day off Friday, so make it even longer than usual. So why not make a good use of day off? So here I am solving the task 1 of week 75. Let's get on with it. By the way, did you notice that this week 75 challenge blog has got some quite interesting information? Looks like we did it 100 plus contribution in last 3 consecutive weeks, so it's quite a big thing. The only time we did this before was week 1 and 2 consecutive weeks having 100 plus contributions. So, well done, team the PwC. And it's not just the regular Perl and Raku contribution, even the guest contributions getting bigger and bigger. So cool. And icing on the cake is even getting more popular in the GitHub. We got a 147 for 70 people that started and 2,130 pull requests. Oh, that's a lot. And also we have regular reviews, Perl and Raku, by Colin Crane doing the Perl review and Andrei Shitov doing the Raku review. And we had a new member join last week, Nino Vieira from Portugal. Oh. Okay, let's get back to the task. So task 1 is so you are given a set of coins which is in at C, assuming you have an infinite amount of each coin in the set. Okay, so write a script to find how many ways you can make a sum $S, again given $S, using the coins from the set at C. So if the coins you are given is 1, 2 and 4, find out the ways you can make a sum 6. Without going into the programming, if you just do it manually, so you'll think of, okay, if I put one coin of 1 6 times, that will make 6. Or if I make a coin of 1 4 times and take 1 of 2, that will also make 6. Similarly, so these are the possible ways you can manually think of. I remember when I thought of this task, I had not solved this before, so I thought, okay, I'm going to just give as my manually. I thought of the solution. I said, okay, this should be your possible output. However, when I actually tried to solve it, then I found out the difficulties. It's not as simple as I thought initially. Hence the reason I gave it as a task 1. Task 1 is generally tends to be simpler than the task 2. But it turned out coin sum is more difficult than it was supposed to be. But anyway, it's a challenge, so let's take it. So let's get on with the job. So here we go. So let's start with this usual ch1-1.pl. So while we're doing this, to solve this problem, I did some googling and to figure out if there is a better approach to solve this problem. I came across a term called dynamic programming. Never heard of before. So I thought, okay, what the heck is this dynamic programming? And I read about one or two blog about dynamic programming, and it turned out if I use dynamic programming technique, then solving this coin sum task would be a lot easier. So I had to get my head around dynamic programming. So I watched a couple of YouTube video explaining the dynamic programming, and that gave me good idea about what it is all about, and I'm going to use the same technique, dynamic programming technique, to solve this problem. Let's see if it makes sense to you. So Hazel coins, I'm just using the standard default given in the task itself, so I'm just saying. So the coins given are 1, 2 and 4, and the sum, default sum expected is 6. So here's 6. So let's get on, before I do anything, let's get on the method. So it's going to be, let's call it coins sum, and it's going to receive the list of the coins and the sum you are after. So first thing first, find out the size of the list, how much coins you have got, different type of coins, unique. So size is gonna be dollar hash dollar, if I can type properly, hash dollar coins, and if there is nothing in the list, just return 0. Return 0 if size is -1 or sum is less than or equal to 0. So no point doing anything further. So okay, as you mentioned, that to solve this task I have to use the dynamic programming, which is the recommended way of solving this type of task. So to solve this task I have to create a matrix. So the matrix is going to be m by n matrix, and across the row I'm going to have the sum value starting from 0. So column would be 0, 1, 2, 3, 4, 5, 6 up to whatever the total sum. So in this case it's going to be 0 to 6, and across the row is going to be the coins starting from the 1, 2 and 4 is in the sorted order. So the row 1 is going to be for coin 1, and the value is going to start, sum is going to start from 0, 1, 2, 3 up to 6, and the row 2 is going to be coin 2, and the sum across the row is going to be the sum 0, 1, 2, 3 up to 6. So we have to build up that matrix, and that's going to make the task a lot simpler. So let's create a placeholder for matrix. First thing we have to do is make the first column of each row and put it 1, because that's the only way you can get the sum of total of 0. So without making any further instruction, I'm going to just set that. So I'm going to do matrix first column, set it to 1 for 0 dot dot size plus. So every row first column will have a value of 1. But the fun part starts now. Let's deal with for the column. We have to fill up the rest of the column and rows in the matrix, and then we have a solution. So let's start with for each my $I. So I'm going to start with zero dot dot size, and then go across the rows. So it's going to be minus $j, which is my total value sum that I'm after. It's going to be, because we already filled the first column, so I'm going to skip the first column. So I'm going to start with 1 dot dot and the total sum, which in this case is going to be 6. So we're going from 1 to 6. We already filled up the first column, so let's do it. And in this dynamic programming there's something called, you either take it the whole coin or you just don't take it. You can't take partial. So list whole is saying I'm gonna include the current, which is by default I'm going to set it to 0, or exclude, and then you just add up. That's how you solve. Okay, so now let's check it. So if the coins, before we even do that, I have to get that string to a list first. So what I'm going to do is, I forgot to make the basic change. So if missing coins unless defined coins die missing sum unless defined sum, and then I am gonna just do some cleaning. Let's do points, get rid of all this space, and then usual this become split by comma all the coins. That give me list of reference of array containing all the coins, and then this would, okay. So I missed that bit. Okay, let's see. So now I'm gonna be, so look at the coins we're gonna start with. So if I say coins of the first coin, which is the coin 1 in our case, so $I is less than or equal to the sum value, which is gonna be 1 as well. Remember, we skip the first column, which is 0. Less than j. So j is the sum. So if this ends, I'm going to include. So include current is going to be matrix. So you're gonna do, you take the current row, which is $I, and the column is gonna be $J minus the coins of I, $I. That's the trick I learned watching the YouTube video. So that's how you get decide whether you want to include the current coin or not. So that correct? $J, yes, sum minus coins of whatever at this position. Now let's say whether we're going to exclude the current or not. So if $I is greater than 0, i.e. you're not in the first row. If you're on the first or second row, then you can decide whether you want to exclude or not. So say exclude current is going to be $matrix. Sorry, it has to be there's the reference to a list. So it's a two-dimensional matrix. So it's going to be matrix. So go to the previous row. So it's going to be I minus 1, but stay with the same column. So it's going to be $J. Yeah. Once you get this, then we are ready to fill the matrix. So we're going to be matrix $I, $J is going to be include current plus exclude current, and that's it. So if you just done it, and the final is the sum is going to be matrix. Remember I told you the row is the sum of the coins. So it started from 0 till the total sum, which is 6, and across the row is the actual coin. So the answer is going to be in this cell $size $sum. Basically the bottom right corner in the matrix has the answer. After filling up the whole matrix, that's where you go. So that's my coin sum. Let's just run it. So what are we gonna do? We're gonna just call this method passing the command line parameter. So print coins sum passing coins and sum. So I hope there's no more typo in this nice little script. Let's run it. So I'm going to just run it with the default values. Okay, what's wrong? Line number 37. Okay, so it has to be arrow is not a list, it's a reference to a list. using curly bracket. Line number 51. Where is line number 51? Okay, got an extra curly bracket. So cool. So it says 6 different ways. So I'm going to try another example from the same task. Yeah, no. Okay, so that's the only one. So I can. So that's it. So we just solved the task 1, coin sum. Let me know what you think. Do you think it's nice and clean way of dealing with coin sum using DP, dynamic programming? Thanks for watching this video, and if you do like the video, please subscribe the channel. Thanks. Bye.